So before we move on to looking at the individual tools in ExpressPCB, I want to talk a bit more about the size and position box. And what we will be discussing will pertain to how board edges, traces, and lines are drawn. Now, we'll talk about how it pertains to rectangles and arcs and other goodies in their own separate videos. Now, first of all, I want you to feel free to skip this video. I am making this video because I sometimes like to get into the minutia of a program and, well, I just found the subject of this video very interesting. And knowing this information also helped me when I was designing some odd custom parts. Now, we have seen that the data fields in the size and position box will change as you select different entities on the screen. So let's look at what the information in those data fields actually mean and how it pertains to your drawing. On the screen, we have a very full and convoluted drawing with a lot of different elements in it, a board edge, 4 lines, and a trace. With nothing selected, the size and position box has 9 data fields. Now, left to right and top to bottom, they are X, right, width, Y, bottom, height, angle, sweep, and length. Now, if I select the entire board outline like this, you'll see that the data fields now have numbers in them, and all of these numbers are referenced to the origin point in one way or another. Now here's a board that's a little clearer. Let's take a look at the X and right data fields. X says 0 and right says 3.8. Now we know the board is 3.8 inches wide, so that 3.8 in the right data field makes sense. But what about that 0 in the X field? Those two numbers, X and right, refer to the top of the board. That horizontal board edge at the top starts at an X of 0 and ends at an X of 3.8. And that 3.8 is in the right data field. Those two data fields line up with the width data field, so I believe they can be considered as all of the information I need to know about the top edge of my board. It starts at an X of 0 and moves to the right and ends at an X of 3.8. The width data field tells me how wide the entire board is, and its width is 3.8 inches. But wait, you could say that the bottom of the board also starts at an X of 0 and ends at the right side of the drawing at an X of 3.8. Well, no it doesn't. And you'll see why in a minute when we discuss the bottom edge. So here's what I think is going on. Now, board edges, which are really polygons, have a starting point and an end point. Lines and traces do too. I can draw a line from left to right, or right to left, or top to bottom, or bottom to top, or even at a crazy angle if I want to. Where and how I start drawing that line or trace changes how it is displayed in the size and position box. If I look at the Y data field for the entire board, it says 2.5 inches, and the bottom data field says 0, and the height says 2.5 inches. So I am assuming that it is saying that the left edge of the board is starting at 0, and that is the number in the bottom data field. The left edge ends at a Y of 2.5, and that is the number in the Y data field. The height data field tells us that the whole board is 2.5 inches high. Now this makes sense and is a good way to see how big your board is height and width-wise. Just look at the width and height data fields. These two fields are all you need to know to see the size of your board. The other data fields describe some of the edges of the polygon that make up your board. Also note that below the height and width fields is a data field marked area, and it tells us the size of the board in square inches. So right now, when we select the entire board outline, and this will apply to any polygon or rectangle, the size and shape box is telling us the overall size of the polygon and some info about the left edge and the top edge. But what if we start selecting the individual sides that make up our polygon? Now this is where the size and position box comes in handy, telling us much more information about the individual elements of our polygon. So let's select just the left edge of the board like this. Now the size and position box data fields have changed to X, end X, delta X, Y, end Y, delta Y, angle, sweep, which is grayed out, and length. Now this is telling me that the left edge of the board has a starting XY of 0, 0 as reference to the origin point. Now that's the bottom of the edge, The top of the left-hand edge has an end x of 0 because it is a vertical line, and an end y of 2.5 because it is 2.5 inches above the origin point. Now, the delta x field is 0 because there was no change in the x dimension. But the delta y field says minus 2.5, meaning there was a change in the y of 2.5 inches. The length data field also says 2.5 inches and tells us how long the line that makes up that edge is. And we can determine from the info in the data fields that this line was drawn starting at the bottom at the origin point and straight up 2.5 inches. Now, the direction a line or a trace or whatever is drawn is important in understanding the data fields when looking at an entity. It is also important in understanding what the angle data field means, and I will talk about the angle data field in a moment. Now, one interesting thing is that the delta y says minus 2.5. Now, I don't understand this. The edge is changing positively from 0 at the origin point to 2.5 inches above the origin point. The delta y should say 2.5, not minus 2.5. And it says the same 2.5 whether I have the origin point set to positive above or positive below. Now, of course, this minus 2.5 could be correct, and I am just not clever enough to understand why it's giving me a negative value. But the right-hand board edge displays the same weirdness as we're going to see soon. Now, if I come up here and select just the top edge, you can see that the x is 0, like it should be, and the end x is 3.8 inches. The delta x reads correctly as a positive 3.8 inches because our positive numbers are to the right of the origin point, and the line has increased its length 3.8 inches. Now, the y is 2.5 inches, and that's correct. And the end y is also 2.5 inches because there was no change in the y dimension. And the delta y shows 0 inches, indicating that this is a horizontal line. This means that the top edge obviously starts at the left and goes to the right. Now, let's take a look at the right-hand edge. Its x is at 3.8, and that is correct, and its end x is also at 3.8. Again, that is because it is a vertical line with no change in x, and the delta x of 0 inches reflects that. The y is 2.5, and that is correct because this edge starts at the top of the board. The end y is 0, again correct because the right edge ends at the bottom of the board where the y value is 0. But the delta y says positive 2.5. Now again, I don't understand that. We went from 2.5 to 0. I would think it would be a negative change. Now, if I'm missing something about this, please let me know. And lastly, the bottom edge of the board. It has an x of 3.8 and an end x of 0. And that's why I believe when we select the entire board, the x and right data fields are referencing the top edge of the board. The delta x for the bottom edge says it is a negative 3.8. And I like that because it is saying we're going from a positive 3.8 to 0. And that is a delta x of minus 3.8. Now, why doesn't the delta y follow the same convention? I don't know. Oh well, we all need a little weirdness in our lives. I've always thought a little weirdness now and then is good for you. So, showing how the numbers work in the size and position box data fields, we can conclude that the board edge was drawn starting at the origin point, going vertically 2.5 inches, and then to the right 3.8 inches, and then down 2.5 inches, and then right to left 3.8 inches back to the origin point. Let me touch briefly on the angle data field. I'm going to change drawings for this. So here is a drawing with 4 lines and a compass in it. Let's take a look at the 4 lines. The top one was drawn from left to right, the right line was drawn from top to bottom, the bottom one was drawn from right to left, and the left side was drawn from bottom to top. Now, I have a reason for ordering them this way. If I look at the compass, we can see that 0 degrees is pointing to the right, 90 degrees is pointing straight up, 180 degrees is pointing to the left, and 270 degrees is pointing towards the bottom. Now, how I draw my line determines the angle of my line. If I come over here and I select the top line, you'll see that its angle is 0 degrees. And that 0 degrees is determined by where my line starts. So my line starts here and goes this way, and that is 0 degrees. If I select the bottom line like this, you'll see that its angle is 180 degrees. And that is measured from the starting point right here and going to the left, just like that, just like it is up here on the compass rose. Now, of course, if I come over here and select this line on the left, you'll see that its angle is 90 degrees. And if I come over here to the right-hand side, its angle is 270 degrees. And that is because I started at the top and I ended the line down at the bottom. Now, this holds true for our board edge, and we can look at each side and we can tell from the angle where the polygon edge started and stopped. So if I select this one, you'll notice that the angle is 90 degrees, meaning it started down here and stopped up here. This one is 0 degrees, meaning it started over here and ended here. Same with this one, 270 degrees, started up here, ended here, bottom line. 180 degrees, started on the right, ended at the left. Now I'm going to cover angles more probably in the video on traces and lines. Now we're also going to discuss how angles work with arcs in greater detail in another video. And that's going to be a fun one, but at least you can see here what is going on with the angle data field. Let me change drawings again. Now I have 4 lines here, and I just want to show how they appear in the size and position box. Now this info will also pertain to traces. If I select this top line, which was drawn from left to right, we can see that it has an X of 1.3 inches and a Y of 2.2 inches, which is where the line starts, and an end X of 2.3 inches and a delta X of 1 inch. Now that makes perfect sense. 2.3 minus 1.3 equals a line length of 1 inch. And the length data field also reflects that. Now, of course, the Y and end Y are at 2.2 inches because there was no change in Y as indicated in the delta Y field. And its angle is also 0 degrees. Now, if I select the bottom line, which was drawn right to left, the X is 2.3 and the end X is 1.3 and the delta X is negative 1 inch. The length field also says that the line is 1 inch, and the Y, end Y, and delta Y stay the same at 2.1 inches. And also note that the angle of this line is 180 degrees. Now let's take a look at the 2 vertical lines. We'll select the left one, and this one was drawn from bottom to top. When I click on it, I get an X of 1.3 inches and a Y of 0.3 inches. The bottom is the starting point of my line. The line has an end X of 1.3, again, because there was no change in X dimension, and an end Y of 1.3 inches. The delta Y says it is 1 inch negative, and I still think it should be a positive 1 inch. Set me straight on this if I am wrong. And the line has a length of 1 inch. Now, the next line over here was drawn from top to bottom. It has a starting X of 2.3 inches and a starting Y of 1.3 inches. The end X is 2.3 inches, indicating a vertical line, and an ending Y of 0.3 inches. The delta Y is a positive 1 inch, and again, I think it should be negative, and the length shows it as 1 inch. And remember, that weirdness with the delta Y affects lines and traces both. They both display a negative delta number when you think it should be a positive number. At least I think it should be. Now, traces behave the same way as lines with their information in the size and position box, so we're not going to do a demo for traces here. And of course, we'll talk about rectangles, arcs, ellipses, and polygons, and how the size and position box displays their data in detail in their own videos. Now, I can't wait to talk about ellipses and arcs. That is a subject that is going to drive you crazy. Okay, is this really important? Are you going to throw your hands in the air, cuss a blue streak, and scare children and animals for miles around and be unable to use ExpressPCB Plus and just go back to wire wrapping your circuit boards if you don't know about all the data fields in the size and position box and what they mean? Well, no, of course not. But it is fun to know what they mean, And if you're designing a custom part at some point and you enter a number and the entity doesn't quite do what you thought it would, knowing what I showed you here will go a long way to explaining what happened. Okay, I guess in the next video we're going to dive into the wonderful world of holes and pads. And I'll probably tell you more than you ever wanted to know. In fact, as a word of warning, I divided the video on holes and pads into 3 separate videos. And no, it's not to get more views. I did that because if I only made one video on them, it was going to be well over 30 minutes long. Okay, after that warning, hopefully I will see you soon.